Okay, going to work on the Exam 1 review. Number 1 I actually did in class, but I'll redo it. Katie sells perfume. She makes $40 a day plus $6 for each bottle of perfume she sells. So what we do, we're trying to find a function or an equation that relates her income to the number of bottles of perfume she sells. So I'm going to assign two variables. Y is going to be equal to her income, or I'll say daily income. X will be the number of bottles of perfume she sells in a day. So what we can do is we can say that the amount of money she's going to make per day is the $40 plus 6 times each bottle, so 6x. If we rewrite this as y equals 6x plus 40, just switching the order, then that looks like y equals mx plus b. So we have the equation. That was the first part. They wanted us to get the equation. Now we actually want to graph it. So the way I'm going to graph this is going to be x over here. It's going to be y over here. And now I'm going to mark out our y-intercept, which is 40. So I'm going to go up, let's say I'm going to count by 5s, 5, 10, 15, 20, 25, 30, 35, 40. And that'll be 1 point on my graph. And then my slope of this line is 6, same as 6 over 1. So I'm going to rise up 6 and move to the right 1. So for me, 45 would be here. 46 would be right above it. I move to the right 1. I'm just going to mark off 1, 2, 3 this way. So I go up 6 and over 1. 1 would put me here. And then I draw a line going that way. And notice that I do not have any line back here to the left because it doesn't make any sense for her to sell negative bottles. So that's the graph of this linear equation. All right, number 2. Number 2, determine if these lines are parallel, perpendicular, or neither. Sketch both lines. So the first line is 3x minus 5y equals 10. Second line is 5x plus 3y equals negative 9. Now in order to determine if they're parallel, perpendicular, or neither, I need to compare their slopes. So what I'm going to do is for each line I'm going to solve for y. So on this one up here, I'll move 3x to the other side by subtracting it. Get negative 5y equals negative 3x plus 10. Then I divide everything on both sides by negative 5, negative 5, negative 5. And I'll be left with y equals, let's see, negative over negative is positive, so that becomes positive 3/5 x. And then 10 divided by negative 5 is negative 2. So the slope of my first line is 3/5. Now on the other line, same thing. I subtract 5x on both sides. That'll leave me with 3y equals negative 5x minus 9. Divide everything by 3, 3, 3. I'll be left with y equals negative 5/3 x minus 3. The slope over here is negative 5/3. So now I compare the two slopes. They are not the same, so it's not parallel, but they appear to be negative reciprocals. Or another way you could look at it is if you take the two slopes and multiply them together, multiply straight across, negative 15 over 15, you get negative 1. And whenever you get negative 1, that means that these lines are perpendicular. So perpendicular is the answer for this. Now it also asks us to sketch these lines. So what I'm going to do is I'm going to use my information up here. I have in both of these equations here, I have y equals mx plus b. So let me start with line 1. I'll do that one in red. I go down negative 2. That's my y-intercept. And then from that point, I use the slope, which is 3 over 5. That means up 3 to the right 5. So I'm going to move up, let's say here, 1, 2, 3, to the right 5, 1, 2, 3, 4, 5. So over 5, put a dot there. And then I connect those with a straight line. That's close enough. Now on the other line, which I'll do in blue, I go to -3, that's my y-intercept, which puts me down here. And then my slope here, -5/3, means down 5 to the right 3. So I need to go down 5 here from this blue point. And uh-oh, I'm going to be off my graph. I'm out of paper here also. So let me grab this real quick and go to a new page. Just extend this down. So from that blue one, I'm supposed to go down, what was it, down 5 to the right 3? Yeah, down 5 to the right 3. So down 1, 2, 3, 4, 5. So down 1, 2, 3, 4, 5 puts me about here. And then, oh, that's not a point, sorry. Okay, and then to the right 3. So 1, 2, 3 down, puts me about right there. Then I connect those with a straight line. Let's see if it comes in blue. No, it's going to be red. Oh well. There we go. And you can tell that these hit at a right angle. Well, it appears they do, which confirms that these were perpendicular. All right, let's go to the next one, number 3. Find the equation of the line that is parallel to this line. So I'm given a line L1. It's 3x minus 5y equals 10. I want to be parallel to that, but I want to go through this point, the point 10, -4. Now, this line is the one from number 2. We just did that line. So we already know from what we just did in the previous problem that the slope of this line was 3/5. And so what we need is our line, the line that we're looking for, to be parallel, which means we're going to use the exact same slope, but we need it to go through this point. So now I'm going to use this equation. I'm going to replace our x1 with 10, our y1 with -4. So that means y minus -4 equals our slope, 3/5. X minus x1 was 10. So this is really y plus 4 equals, now I'm going to distribute 3/5 through here. We get 3/5 times x is 3/5 x. And then minus 3/5 times 10 is the same as 30/5, which is 6. So now we'll just subtract 4 on both sides. And you'll get y equals 3/5 x minus 10. So that is the equation of the line that is parallel to the one we just found, but through this other point. And it asks you to sketch the 2 lines. What I'm going to do, go back here. It's this one right here. It's this line right here. You know what? I'll grab it and take it down here. Okay, but it's not the blue one, so I'll take that blue one out of there. Good enough. Okay, so that was the line we started with. The one that we found was this one. So what we're going to do is we're going to go down to -10. So that was -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, right there. Put a dot. And then we'll use the same slope. So we go up 3 to the right 5. So go 1, 2, 3 to the right 5. 1, 2, 3, 4, 5 right there. Put another dot. And then draw a line. Oh, wow. Getting lazy now. I'll just go ahead and put this in like this. It's not a perfect drawing, but it's pretty darn close. These are supposed to be parallel. I was a little bit off on these marks, but those are the two lines sketched. The original line and then the line that we found that was parallel. And if you check, if we were to go out 10, like remember the point was supposed to live on this is 10, -4. If we were to go out 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and go down 4, 1, 2, 3, 4, we'd be on that line. So that's just verifying that. Boy, they don't look parallel, but don't worry about that. Okay, next one. So for number 4a, we want to find the domain of f of x equals x plus 2 over x squared minus 1. So the only thing we have to be concerned about is the possibility of division by 0, that this could possibly be 0 at some point in time. So I want to make sure that x squared minus 1 is not equal to 0. I add 1 to both sides. X squared cannot be equal to 1. I take the square root on both sides. Anytime we do that, we have to do plus or minus. And the square root of x squared is x, and the square root of 1 is 1. So what we're saying is x cannot be 1, x cannot be -1. On a number line, if this is -1 and this is 1, we do not want those points, but we can have anything we want in between, anything to the left over here, anything to the right. So the way we write that is -infinity to -1, parentheses, union, -1 to 1, union 1 to infinity. We did a couple of those in class, so that's what I'm looking for. For 4b, I want to find the domain of f of x equals square root 12 minus 4x. So here what we need to make sure is that the radicand, the thing underneath the square root, cannot be negative. So we need 12 minus 4x to always be greater than or equal to 0. And so to solve this, all I need to do is add 4x to both sides. 12 must be greater than or equal to 4x, and then divide both sides by 4, and you get 3 must be greater than or equal to x. Or you could say x must be less than or equal to 3. So if this is 3, we need our x to be less than 3, which means to the left, but x can also be 3. So it's okay to be 3 and everything over here. So we write that -infinity to 3, but this time we put a bracket on 3. That's what I'm looking for there. Okay, for 4c, we want the domain of f of x equals 3x minus 1. There are no square roots here. There are no fractions. In fact, that's just a line. If we were to replace the left side with y, the whole thing with y, the whole thing with y, that's just y equals mx plus b. Lines are defined everywhere. So we have, well, at least non-vertical lines are defined everywhere. So we have that. All right, let's move on to number 5. For number 5, let's see, 5a. Well, I should write down for number 5, I give you a function. The function is f of x equals -x squared minus 3x minus 8. And for 5a, I ask you for f of -3. So we replace every x with a -3. So notice how I do this. Be careful here. This x that's being squared, whatever your x is, the whole thing has to be squared before you put in this negative sign. So I need to have that -3 in here first, and then square it, then come in with the negative sign. And then notice here on this x, that's -3. So let's see. -3 squared, this part, is going to be 9. But I have the negative in front, so -9. Then here, -3 times -3 is +9, and then minus 8. These 9's cancel, and you're left with just -8. Careful with your signs there. 5b, find f of -4t. So again, I'm going to rewrite the function. Everywhere I see an x, I replace it with -4t. And now I square this first, and that means -4 times -4 is 16. T times t is t squared, and I still have the negative in front. So -16t squared. Then negative 3 times negative 4t is positive 12t, and then minus 8. And that's it. Okay, 5c. I want f of 2v minus 3. Again, we have the negative out front. I'm going to replace the x with 2v minus 3. I'm going to square that. Then minus 3 times 2v minus 3, and then minus 8. A couple of things we need to do here. We need to square this, right? Square that. So I'm going to do that up here on the side. 2v minus 3 squared is the same as 2v minus 3 times 2v minus 3. And I will FOIL this like this. So I get 4v squared minus 6v minus 6v plus 9, which gives me 4v squared minus 12v plus 9. That's going to be sitting in front of this minus sign. So the minus sign is then going to go through this and change all the signs. So I'm going to do that all in one step. Distribute the negative. I get negative 4v squared plus 12v minus 9. So all of that, okay, is this part right here. Then on the next piece, I have negative 3 gets distributed through. So that gives me negative 6v plus 9, and I still have that minus 8 way out there in the end, minus 8. And now what I can do is I can collect like terms together and get a final answer. So negative 4v squared. See, I have 12v. I take away 6v. That leaves me with 6v. Negative 9 plus 9 is 0. Then I have the minus 8. That's it. Okay, quick pause here. All right, let's move on to number 6. I want to sketch and list the transformations of negative square root x plus 3 minus 2. All right, so first thing I want to notice is that this is a square root function. So I already know what it's going to look like, the basic shape of it. Okay, the basic shape of this starts out at the origin and does this, like that. Now, the next thing I have is that inside the function, next to the x, I have a plus 3. Anything that happens inside the function next to the x is a left or right shift, and you actually go opposite of what you think. So here, instead of going plus 3 to the right, actually go 3 to the left. So I'm going to go left by 3. And then on the outside, I have a negative outside the function. That's going to flip me over the x-axis, or reflect over the x-axis. And then the very last thing to happen is that I have a minus 2, which is going to move this whole thing down 2. So let me do that step by step. First, let me take this red one. Let me move it to the left 3. 1, 2, 3. And then it would do something like that still. And then I'm going to flip it over the x-axis, which makes it like a mirror image of itself over the x-axis. And then I'm going to move the whole thing down to 1, 2. So this will be my final picture. I think I'll do it in black. Make it solid. So something like that. All right, so if you just list out these transformations like that, that's acceptable, and then just give me a graph. All right, number 7 is the same thing. Transformation function is 3 absolute value of x minus 1 plus 1. So the fact that this is an absolute value function tells me that the toolbox function is going to look like a V. So I know my original function starts out here, comes up like that, comes up like that. And then inside the function I have a minus 1 next to the x. So I go opposite of what I think. That means I'm going to actually go to the right one. The 3 in front is, we looked at this 2 ways. You can say it shrinks it horizontally or it stretches it vertically. I'm going to say shrink or compress horizontally. And then the final thing here is the plus 1 that's going to move it up 1. So let me do my transformation. I'm going to move everything to the right one, which is going to put me here. Okay, that's moving it to the right one. Now I'm going to shrink it horizontally. I'll do this in blue. It's going to take the side here, and it's going to push this side in. It's going to push this side in, which is going to make it more narrow, like this. And then I'm going to move the whole thing up 1, which takes this point here and moves it up 1, I'll just say here, and it keeps its narrowness like that. That's what I'm looking for. All right, next one. Number 8. So for 8, I give you 2 functions. First one is 2x squared plus 5x. The second function, g of x, is 2x minus 3. And for part A, I ask for g minus f of x. That means you're going to take the g function. You are going to subtract, and remember subtraction, you have to be careful. You're going to subtract the f of x. So I'm going to write down what g is first. That's 2x minus 3. Then I'm going to subtract, and I must subtract the entire function, so I'm going to subtract everything, all of f, and f was 2x squared plus 5x. And now I must distribute that negative through. So I get 2x minus 3 minus 2x squared, and then minus 5x. Now collect like terms and write it in descending order. I have negative 2x squared. Let's see how many x's I have. I have 2x, take away 5x is negative 3x, and then constant I have just negative 3. So that is g minus f. Let me try and squeeze 8b right here. For 8b, I want to do this, which means multiplication. So that just means I take the f function, I multiply it times the g function. But I have to be real careful here because I have multiple terms. I'm going to put f and g in parentheses. So f is 2x squared plus 5x. G is 2x minus 3. And now I will expand this, or if you like, we call it FOIL. Here to here, here to here, and then here to here, here to here. So when I do that, I get 4x cubed, and then 2x squared times negative 3 is negative 6x squared. Then 5x times 2x is 10x squared, and then 5x times negative 3 is negative 15x. Collect like terms. Negative 6x squared plus 10x squared is plus 4x squared, and then minus 15x. So that is f times g. All right, 8c, I want to do composition. So what I think I'm going to do for 8c is I'm going to push these down so I can keep my functions right there. So 8c, I want to do f of g of x. This means you take the f function, and inside of it you put g of x. That means I take the f function, and inside of it I put 2x minus 3. Now that means I'm going to go to my x function. Everywhere I see an x, I'm actually going to replace it with 2x minus 3. So it becomes 2 times 2x minus 3 squared plus 5 times 2x minus 3, which I will accept that on the test as your answer. You can clean that up. You can expand it all out. 8d is the other way around. I want g of f of x. That means you take the g function, inside of it you plug in the f function. So replacing f with what it is, 2x squared plus 5x, that 2x squared plus 5x gets replaced into the g function wherever I see an x. So the g function is just 2 times whatever I give it, which is 2x squared plus 5x, and then minus 3. And then just distribute that through and you're done. All right, so that takes care of 8. Number 9. A. You're asked to factor 3x to the 4th minus 27x to the 2nd. So first thing I'm going to do is pull out a GCF. I realize that 3 goes into both 3 and 27. I also notice I have an x squared. That'll leave me with an x squared, and then minus, let's see, 3 times 9 is 27. I already have x squared, so that's it. But then I need to notice that inside the parentheses, this is actually a difference of 2 squares. So I can rewrite that as x plus 3 times x minus 3. I'm done. For 9b, I have 4x squared minus 9x plus 2. There's no GCF here. So I look at, there's 3 terms. So I'm going to do AC method, which means I'm going to take 4, I'm going to multiply it by 2, that gives me 8. Take the number in the middle, which is negative 9. Try and come up with 2 numbers that multiply to be 8 and add up to be negative 9. They're actually negative 1 and negative 8. Those multiply to be 8, add up to be negative 9. So I rewrite this problem. I just rewrite the 2 ends. And then in the middle, that negative 9x, I use these 2 numbers to rewrite it. So I use negative 1x minus 8x, and then I had that plus 2 at the end. Then at this point, I have 4 terms. I can do grouping on this. Out of the first 2 terms, I can pull an x out, be left with 4x minus 1. Over here, I need a 4x minus 1 also. So the way I could get 4x to become an 8x is to multiply by, negative 8x is to multiply by negative 2. And just check for yourself. This times this is this. And this times this is this. So that does work. And now that these 2 things match, all I have to do is rewrite it. Put the 4x minus 1 here. And then the other 2 things that were in front go into my next parentheses. And I am done. Okay, 9c. For 9c, I have 2x cubed. Oh, I'm getting a phone call. Hold on just a second. Okay, sorry about that. Here's our function, or I'm sorry, we're trying to factor this expression. And for this one, we just notice there's no GCF, so automatically we look at the fact that there's 4 terms. We can factor an x squared out of the front 2, which leaves me with a 2x minus 5. On the other one, we need a 2x minus 5 also. To turn a 2x into a negative 2x, I need to multiply by negative 1. And just checking negative 1 times that gives me negative 2x, and negative 1 times negative 5 gives me positive 5. So that will work. These 2 match. So I just write that out front. And then write the other 2 pieces out in front of that, x squared minus 1. And hold on now, x squared minus 1, that second factor there is a difference of squares. So it can go down a little bit more to x plus 1 times x minus 1 using the difference of squares formula. That's it. All right, let's get on to the last problem on the review here. 10a. It's supposed to determine if these are functions or not, and if they are, to write the domain and range. So on this one, this fails to be a function because it fails the vertical line test. If I draw a vertical line there, it hits it in 2 places. So 10b, not a function. So if it's not a function, we don't even have to talk. Can't even talk about domain and range. 10b, we have something like this out here at 1. It's a v. That is a function because any vertical line I draw will only hit the graph in 1 place. So it is a function. I'm just going to put f, check. And then as far as domain, notice that if I move anywhere on the x-axis and look up, I'm going to hit the graph somewhere. I'm going to hit the graph somewhere. And so the domain is everything. Negative infinity to infinity. And then for range, I get on the y-axis and I look left and right. So if I look to the right and to the left here, I don't hit anything. I don't hit anything. Not until I get to 0. When I get to 0, I hit. Once I'm past 0, I start hitting function. So everything for range would be everything from 0 to infinity. And I do include 0 because there was actually a point at 0. So bracket 0 to infinity. 10c. Graph has an arrow here. It does this, does something like that. Okay, so this is a function because it passes the vertical line test. It also function, yes. the domain of this, it exists everywhere. So if I move to the left, oh, I'm going to sneeze. If I move to the left, I'm always going to hit function somewhere. Even if I come over here, it's going to be down there, somewhere down there, way down there. And as I move to the right, I hit even way up here. It's going to be hitting somewhere up there. So domain is everything. And then for range, if I look left and right on this one, if I'm down here, I'm going to hit something out here all the way down forever. And if I come up, I'm still hitting. I'm hitting. And to the right up here, I hit stuff eventually. So the range is also everything, negative infinity to infinity. And then the last one, 10D, goes like this. This is a function because it passes the vertical line test. The domain, I start out at 0, and then to the right, everything is defined. I have function over there. So it is a function. Domain starts at 0 and goes to infinity. And then the range, also, if I look on the y-axis, I don't start hitting until I get to 0, and then I start hit. And so that goes from 0 to infinity also for range. All right, that's it. Those are the solutions. Hope that helps.